So factoring is when we can break up numbers in terms of their multiplication pieces. So it's really important to be able to factor because that's the building blocks of all numbers. So we can break up factoring into, we can do it kind of two ways. One is factor pairs, where we can break things up into length and width. Okay, so we just have pairs. So for example, for 52, we can have a factor pair that gives us an area of, in this case, we can do like maybe 4 times 13. Okay, so 4 times 13 would represent factor pairs. So we can write it like this. So factor pairs could be 1 and 52. Okay, it could be 2 times 26. And factor pairs could also be 4 times 13. Okay, so for this one, there's only 3 sets of factor pairs. So that's one way to factor, is to do in pairs, and the factor pairs are essentially breaking up into length and width. So prime factoring is slightly different. Prime factoring is breaking it up into the smallest pieces, and we can have more than just pairs. So for 78, we often do, there's two ways to do it. One way is a factor tree. Okay, so I can do, 2 times 39. I can do 3 times 13. Okay, and when we rewrite this, we write this in the factors. 2 times 3 times 13, and that's going to give us, that's going to equal 78. So this is our prime, what we call prime factorization. We break it into the smallest pieces. None of these numbers can be broken up into smaller numbers. Okay, the other way we can do it is, and this is just a different way to do the same thing. We can use these factor boxes, and we can divide 2 into 78 and we get 39. We can divide 3 into 39 and we get 13. And all the outside pieces then represent the prime factors. Okay, as soon as we get down to the factor that we can't break down anymore, we're finished, and that represents the prime factors. Okay, so that's factoring. We can do it in factor pairs, okay, or prime factors, and there's different times when we'll use one versus the other. So finding the greatest common factor, we can find the biggest number that is a common multiplier or common factor in these numbers. So we could do it in two ways. We can do it in factor pairs. So I can list out all the factor pairs. So doing 36 and 24. Okay, the factor pairs would be 1, 24. Okay, actually I'm going to do it this way. I'm going to just list them from biggest to smallest. 2 and 12. Okay, 3 and 8. 4 and 6. Okay, so these represent all the factors, and they come in pairs. Okay, so these are pairs, etc. Okay, but those are all the factors. Okay, all of them represent factors. And I'm going to do the same thing here. I'm going to go 1, 36, 2, 18, 3 and 12, 4 and 9, and then we have 6 and 6, so I'm just going to have the 1, 6 in the middle. So then what I can do is I can just look through these factors, and I can see whatever ones are common. Okay, so I can see that 1 and 1 are common, 2 and 2, 3 and 3, and it's not, there's lots of common ones, but what we're looking for is the biggest common one. So 6 at this point is the biggest one, but if I keep on looking, there's one more. 12 and 12 represent the biggest common factor. So the greatest common factor by using these factor pairs is, I can find it as 12. Now this is fairly inefficient. We can find a greatest common factor in a slightly more efficient way by showing the factors, the prime factors, and it looks like this. So I'm going to factor this into prime numbers. So this is going to be 24 becomes, and we can do factor tree here. So I'm going to do 24. It's going to be 2 and 12, 4 and 3, 2 and 2. Okay, so we get 2 times 2 times 2 times 3. So that's my prime factors. I'm going to do 36. Okay, so I'm going to do 36 the other way. Use my little box method. So I'm going to do 3, and this is going to be 12. 3 again, and I get 4. 2 and 2. Okay, so I can write 36 in its prime factors as 2 times 2 times 3 times 3. And I kind of tried lining them up the best I can, because then I can see which ones are common. Okay, so I have common 2's. I have another set of common 2's here. I have one set of common 3's. So if I just group all the common factors, prime factors, I can multiply all the common prime factors to make the biggest common factor. So my GCF I find is 12 in this manner. And for more complicated numbers, this is an easier way to do it. Okay, some people may look at this and say, oh, I can see the largest divisor is 12, and that's perfectly fine. And that's good to be able to do. However, make sure you have some strategy. So this is one. The strategy 2 tends to be a little bit more efficient, especially once we start dealing with bigger and bigger and bigger numbers. So I'm going to put a star next to this one here, because this one tends to be a little bit more efficient once we start getting into big numbers.